Hello and welcome to Let's Learn.net Git and GitHub. We are so excited and glad that you are here with us today. I am not Jamie Singleton. I know you're expecting Jamie. I am James Montemagno. Jamie is out sick today, so myself and John Galloway will be filling in for her. We hope that Jamie gets well soon. And before we get started today, I wanted to take a moment to recognize the individuals that are affected by the tragedy in Ukraine, whether that's family, friends, colleagues, or fellow human beings. Microsoft has made an official statement on what we're doing, and we'll link that in the chat. I encourage you to read that to see what we're doing here at Microsoft. But I'd like for us as developers to take just 10 seconds to remember those affected by the violence right now. So let's do that. Thank you so much for that. And thank you for being here with us. Now, we're excited to share all things Git and GitHub today for .NET developers. And I have some of my favorite people in the entire world here with me because every single one of you is my favorite people in the entire world. And I'm really excited because not only is Git and GitHub such a fundamental piece to the equation when you're building applications or backend services with any programming language, there's really amazing things that you can do as a .NET developer with these tools and services. So what we're going to be doing today is we're going to be talking through some of the fundamentals of Git. So whether you're brand new to Git or you've been using Git for a decade or two, I've been using Git for a while, but I still don't know half the basics, to be honest with you. We're going to bring on Martin Woodward. Does anyone really know anything about Git? I'm not really sure, but Martin Woodward is going to come up first and explain the basics and go through some of the fundamentals. I'm really excited for that. I am sure that everyone is going to learn something there. And then when it comes to GitHub and things like GitHub Actions, my good friend David Pine is going to be coming on to talk about all the things that you can do there. So it's a really exciting time when you combine these two pieces of technologies. Now, wherever you're at, if you're coming from VS Code Day, like that's awesome because you're going to be able to do tons of this inside of VS Code or Visual Studio or any of your favorite IDEs or editors that are out there, or just the command line as well. Now, if you're over there on YouTube, it's super love it if you'd hit that subscribe button, ring that notification bell. We put out new videos and live streams here every single week. If you're over on Twitch as well, hit that subscribe button. Super appreciate that. We're here for you and we want to hear from you. We have our chat room going everywhere over here. So we will be answering questions live. That's why it's Let's Learn.net. You're encouraged to kind of follow along at home if you'd like to try things out over here as well. I'm going to be moderating. I'm not going to try everything at home in real time, but we encourage you to do so there as well. So we'll be dropping links throughout the entirety. But if you have questions, the experts are here to answer them live, and there'll be points and times sort of between each section where we'll be answering questions, and I'll be taking a look as they come in real time there. We also have some world-class moderators from the team here at Microsoft and GitHub actually answering those questions on Twitch and YouTube and Learn TV all live. So we'd super appreciate that if you'd ask some questions that are coming in. But let's get started with one of my best friends in the entire world, Martin Woodward. How is it going, Martin?
Hello. It's lovely to see you, James. It's been a while. So yeah, it's great to be here.
It has been a long time. And Martin gave us a nice, lovely scare by showing up 15 seconds before we went live. So appreciate
that. When have I ever let you down?
You've never let me down ever, and I don't expect you ever to. So I'm super happy. So,
you're welcome.
When people talk about Git, I think that it's kind of a loaded topic. Like there's so many magical tools and things out there. Like before you even get into your thing, I haven't even looked at your slides. I haven't done anything.
Okay.
Why should anyone even care about Git?
Yeah, that's a great question. And it, like you said as well, James, it is like hard to get into. It's not the most sort of user friendly of source control tools. So we'll dig in and we'll talk about what source control is and why Git and things like that. But I will say, if it makes you feel any better, I've been to like maintainer meetings where the people who build Git get together and talk about the future of Git and how to use Git and what features they should add. And these are people who are building Git in Git. You know what I mean?
Yeah.
And they sit around all day trading tips on different Git commands to use and different techniques and things. And so I remember just being sat there and was like, oh, right. It turns out I'm not a complete fraud. Everybody's trying to figure this out as we go along. And so what we'll cover today is the basic kind of commands you need to know to get started, how to use it in Visual Studio, how to use it in Visual Studio Code, how to use it from the Windows command line, things like that. And then, we're just, it's a very much a easily approachable getting started. And then we're going to dig in and understand kind of how Git works under the hood. Because once you understand how it works under the hood, some of the more bizarro things you have to do sort of make a little bit more sense. So that's the plan for today anyway. Hopefully that's good.
Awesome. I love it. Yeah, I'm super excited. I feel like I use a lot of tools and they help me, but then sometimes they don't, and I need to go do some stuff. And sometimes
Yeah.
like I'm on GitHub and it's like, hey, just run these 4 magical commands. And I'm like, that sounds great. I have no idea what it's doing though, but it magically mostly works. And then sometimes it doesn't. And I think
Yeah.
that's the factor. It's like actually good to know this stuff. Well, let's get going. We bring up your monitor. I think you got your slides up ready, right?
Yep. Good to go.
Boom.
There we
That
go.
looks great. All right. Take it away, Martin.
Fantastic. Well, thanks very much. And thanks everybody for having me. Do please drop the questions in the comments. It's great to see you. Great to see you, Jose. Great to see you, Cam. It's really good to have everybody here. So want to keep this as interactive as possible. So please do ask questions. I'm going to kind of stop in a couple of little places and as we do demos and things like that. So that should be good. Hey, Alan. Hey, Cam. Right. So let's get started. As James said, my name is Martin Woodward. Is at Martin Woodward on socials as well. If you want to drop me a line and, send me some abuse on Twitter or whatever, feel free. So James was asking, why do we care? What is version control? So basically, version control is just a place to store stuff, okay? It's just a place to store code, and it's optimized for storing code. It gives you a historical record of those code changes over time, so you can go back in history and sort of decide this was working last night but I broke it this morning, and you get that horrible sinking feeling in the pit of your stomach. So what you can do is go back, roll back the clock, go back to when it was working, and you have a checkpoint of all of the source files at that point in time that was definitely good. And the other thing that version control gives you is the ability to safely work in parallel. Everything I talked about up until now, you could probably do with OneDrive or Dropbox or whatever, or zip files, which is kind of, when you begin development, that's kind of what you do. You just sort of save some files off in a directory after you've lost some data a couple of times, or use OneDrive or something like that. But allowing teams and allowing more than one person to work in parallel is what version control gives you. And so it's really, really good to kind of get used to using version control, get used to have it as part of your core workflow, so that then when you work with a second person, you can actually collaborate. And obviously, if you're doing any work in open source is all shared using the Git version control tool. And so if you're going to be working with open source at all, then you're going to need to know some basics of version control just to be able to do what you need to do. So I'm old enough, I'm very old, as you can tell. I used to have hair. I'm old enough that I remember when there were other types of version control systems that we used in the world, apart from Git. There's 2 different types of categories, really. There's a centralized one and a decentralized version control. I like to say, Git was the first Web3 technology or whatever. It was the first blockchain. It's a decentralized tool that cryptographically stores hashes of things, and it allows it to work across machines without a central server. Centralized version control, examples of that would be like Subversion, TFVC, which a lot of .NET developers are actually familiar with. They're all examples of centralized version control, or Perforce actually, which is still very popular in the gaming industry. And these centralized version control systems have certain advantages and disadvantages to a distributed version control tool like Git. So, for example, Git is great at storing lots of small files. That's what source code typically is. But where Git can fall down is it can fall down if you're storing some large binary files and things like that. Because the way that Git works is it actually stores an entire copy of the source code and all of its history in a compressed format, but it stores that all on your local disk. So when you go to GitHub and you go clone a repository down, as you might have seen, you're actually getting an entire copy of that whole repository with history locally. Now that's fantastic because you can do all your operations locally. You don't need to go to a server. There's no sort of person in the middle, stopping the way that you work. but it does mean you're getting all that code of history. And so if that code had lots of binary files in it, say some VHD, some images, some full Docker containers, whatever, if it contained a bunch of binary files and lots of different versions of them, then that could make that download really slow because those binary files don't compress. So there are some advantages, and that's why you see in the gaming industry, that's why you still see kind of Perforce around a little bit, because it's kind of, and TFEC as well is good for handling those large binary files. And so that's why those, in gaming and things like that, so that's why you see that. But we're going to talk about Git, because that's what like 98% of people use the time nowadays, and what we all use for version control. Otsil, the reason why we need to do version control, why we need source control, is how often when you're making, like when you're coding, you do some coding, you make some changes, and then you do something and everything breaks. Like stuff doesn't work. And it was working this morning, or it was working an hour ago, but stuff's broken now. And you want to kind of roll back history and just decide, okay, I'm going to see what's changed between these two versions, and then I'm going to figure out what changed and what broke. That's why, as individuals, we start to use version control, so we can get a bit of history and we can roll back the clock and see what happened. And we can also remind ourselves in the future what we did changes over time. But once you start working in a team, source control is essential to be able to share files with people. Because when you share a change, when you make a change to your source code base, quite often a single change involves 2 files, 3 files, 50 files, involves multiple files that you're changing, because you might say adjust a class and then adjust the thing that calls that class, for example, to make something work. So usually it contains at least a couple of files. So that's why we tend to use version control. Hopefully that makes sense. Right. And good to see you, Felix. Great to see you from Kenya. That's fantastic. Okay, we're going to crack on. So we're going to talk about Git today, and we're going to talk about Git, which is a type of distributed version control tool that everybody uses. And we're also going to talk about GitHub, which is where I work. I work at a place called GitHub, which is where the world builds software. You probably know it as the place you've gone to go get free software, to go find the answers for problems in the past, to go download things. That's where open source lives, and that's where the open source community lives. But many, many companies around the world don't just use GitHub for sharing and collaborating in open source. They're also using it to build software, for their companies. GitHub's completely free to get started. So if you've got a great startup idea, you can start there for free, and then you can scale up and pay for extra features and all that sort of stuff. So actually, that's what we're going to talk about today.
We actually got a great question on that specific topic, because there's a few questions from Atsilo and also Sean, which is asking really, what are the differences between those two slides that you just had there? What is the difference between Git and GitHub and other companies like GitLab and other ones that are out there? That's a very top of mind question, because they all have Git in the name.
Isn't that confusing? And people think often that Git is kind of like just shortcut for GitHub. So Git is the version control tool. Git is the tool we're going to use mostly today. That is the thing that allows you to store files on your machine. It's completely open source. I've got a bunch of friends that work on the Git project, but it's a completely open source project.
Got it.
But it's built as a tool that allows you to do version control on your local machine. If you want to share your code with somebody else, then the easiest way to do that is to put it on a website somewhere and share it with somebody. So GitHub came along as a way of taking your Git repository, pushing it to a server in the cloud run by a company called GitHub, who build the GitHub website, to share that Git repository with somebody else. So you can share them with GitHub. You can share them with Azure DevOps. Is a thing that a lot of .NET developers have had experiences as well. Azure repos can store Git repositories and share Git repositories as well. So yeah, so that's the difference. Hopefully that makes sense.
Yeah. Now Git is like the underlying technology that powers the ability to do all the version controlling, all those things, and then all of these are like online storage locations that also offer additional features on top of it, right? Like GitHub
Yeah.
has issues and discussions and planning and all these other things as well, right? So
Yeah, exactly.
so
It's a
it's a
place where
piece.
it doesn't just let you share your Git repository. It allows you to collaborate with your team,
Yep.
but then also like Git isn't the most user friendly of tools, as we've talked about.
Yeah.
Spoiler alert. And so GitHub introduced a thing called the pull request,
Got
which
it.
is a weird term that you have to get used to. It makes sense, and we'll explain why it makes sense in a bit. But it allows you to do a point of code review to say, hey, I think this is a good change. Would you like to pull it into your repository, please?
Got it.
And that point of code review is all done through the web. That's not a thing that GitHub has. Sorry, that's not a thing that Git has. That's the thing that GitHub has.
Got it.
Even I'm getting confused.
Uh-huh.
Git just has branches, which we're gonna do first. And
Got
so
it.
GitHub builds on, and all these tools build on top of the core principles of Git, the core fundamentals, and then make it more user friendly. If you didn't want to know how anything about Git, if you never wanted to type the Git command line, you never wanted to use Git in your local editor, you can go to GitHub, drag drop some files into it, and it just stores them there for you as like
Yeah.
a storage. So yeah, it tries to make things a lot more easy. So hopefully
Lovely.
that makes sense. Great question, everybody. Thank you. These
Lovely.
are great questions.
Yeah. All right, cool. I'll let you crack
Cool.
on.
Right, James, chip in if there's any other good, great ones like that as well as I'm doing. This is brilliant. This is much more fun when it's interactive.
Sounds
Right.
good.
So, some top tools that you should go get if you're a .NET developer and you want to do some Git. I'm going to assume if you're a .NET developer, you're mostly using Windows. I'm actually on a Mac with a Windows VM today, so I can jump around and show people whatever they want. But the kind of tools you're going to want is a good editor. Visual Studio Code, of course, is the best editor of choice. And then you probably, if you're doing .NET development, you're probably going to be wanting using Visual Studio as well. You can get free versions of Visual Studio. You can get like the fancy paid versions as well from your company or that sort of thing. But if you're doing like some kind of UI development with .NET, then probably Visual Studio is the way to go for you. Git for Windows is Git for Windows, and that's what it is. It's a Windows installation of the Git version control tool. You install that and you have it running, and then I like to install a thing called PoshGit, which is a sort of shell for PowerShell, which allows you to use Git more easily. And then finally, I use GitHub Desktop because, again, I can use commands and I can do some command line stuff, but mostly with Git command line, I can kind of do my basics. But if I want to do anything complicated, I tend to have to go, like James said, go look up those sort of commands from Stack Overflow or look them up from somebody's page on GitHub. Can never remember them. And so I like to use a UI to kind of help me, especially if I'm trying to merge changes, if I'm trying to take somebody else's changes and merge them in with my own code and make it make sense. A UI is much easier to do that than the command line, in my opinion. But everybody's different. Use what works for you. So I think we've gone long enough, James, without having a demo. So if it's all right with you, I'm going to jump in and I'm going to do a bit of a demo of just getting started, like the no fear approach of just using Git as somebody who uses it and doesn't need to understand it. So we're going to jump straight in here. So here we go. So let's just wake up my Windows machine and we can get logged in. Sorry, I should have done this a second ago, but there we go. I can't actually type and talk passwords at the same time. Right, so this is me. This is where I live on GitHub. And then what we're going to do is we're going to go into... I'm going to start off in Visual Studio. I'm actually using Visual Studio 17.1, which is the latest preview of Visual Studio. And I'm just going to get started there. I'm going to make some things look bigger. Hang on a second. Ooh, that was exciting. Didn't want to do that, did I? No, I'm just going to leave that for now. We'll make it work. You're all at home. This is good. Right, so...
Go ahead and zoom in a whole bunch there for me.
Yeah, I'm just on that. Yeah, exactly. I'm just on a new... hang on a second. Wait there. Give me 1 second. Nearly. It's been slow. And then do Control-E that way. Sorry. I should have got this tested before it came on. Sorry. It's the new VM I'm in. Right.
I think you can use the magnifier, but when you zoom in on
I
it.
was trying to do it a different way, but it's not working. So I'll just use the magnifier button again.
Yeah.
Okay. So over here on Solution Explorer, what I'm going to do is I've just got a console app. Don't do nothing. It's just a console app, but it's just a basic, Visual Studio solution. But if I right click and say create Git repository, Visual Studio has Git tooling built into it. So you can just use it. So if you do create Git repository, and then you now get a nice dialog that pops up that allows you to create a Git repository. By default, it allows you to use GitHub or Azure DevOps to share your Git repository. But if you just wanted to do it locally, you can just do it locally if you just wanted to store some history locally. But I work for GitHub, so we're going to use GitHub, and that's what a lot of people use. So we're going to create a Git repository. We're going to create a git ignore file. I'll talk about that later. Just go with default, always accept the defaults. I'm going to add a thing called a README file. Again, we'll talk about that in a bit. And then I'm going to push this up to GitHub. I'm going to say, I've logged in. I'm going to say, right, go to GitHub, log in as my owner, console app. And then I'm just going to create this as a Git repository, and I'm going to push it. So let's do that. Sorry about this. Right, there we go. So that is now created a Git repository. It's pushed it, and you see all the way down here, I've got my console application. So I'm in Git. I'm using version control. See, that was pretty painless, wasn't it? No worries there. And if I go to my GitHub and I look at repositories, and I should hopefully now have console app. Let's just see if that's there. And he says, oh, hang on a second. I'll type that in a sec. Right, console app. Right, yeah, there we go. Right, we'll just get this going, and we'll push it, and then we'll get going. There you go, version control up and running. It's still doing its thing, and then yeah, all managed. Okay. So now what we're going to do is we're going to make a quick... So we're now using version control. We're now doing stuff. So if I come in and I'm going to just quickly make a quick change here. Hello. And then save that. And then I'm going to zoom in a second here for you. And then I'm going to... I've saved my file. I've made some changes. I can actually right click on this and say Git, and I can view history of my file, and I can do all the things that I want to do on my file in Git, if you know what I mean. Oops, sorry. I've opened up the CS file. Sorry about this. I'm trying to use Windows and I don't use it very often, so I've messed up for you. Wait there. Right. Hello. Right, and there we go. Make some changes. And you see, because I've made some changes, it's there, and then it's kind of auto-committing them as well as I go along, which is pretty neat. And then I'm going to right-click on this, and I'm going to say Git, View History, and I'm going to come along here, and we can look at the history of Git locally, and it's deciding it wants to just mess me around. Okay, we're just going to do a quick push. Sorry about this, everybody.
I think you got the Git Changes tab by the Solution Explorer right there.
Yeah, I'm just trying to see why that wasn't coming up in history there. Anyway.
I don't actually know, did it push it?
Yeah, that's what I'm wondering. I'm just going to do... I thought it did, but I'm using this new version of the preview, and as you can tell, pushing started. It said it had finished. Let's just do this one more time. And then I was hoping people could follow along. There we go. It just took... For some reason, it was waiting a little while. I think it's because I'm doing StreamYard as well as this, and my bandwidth's not there. So there's the raw repo. But what it hasn't done is added all my files in, which is slightly annoying. So I'm going to go fix this in a second and get this up and running. But this is terrible. This is a bad demo. Right, come in here. Look at this, main. Right, okay, we've got the console app. We're going to right click on that. We're going to say Git. Yeah, right, okay. We're going to go fix this in a second. So give me a second while I get this fixed. I'm just going to close down Visual Studio and reopen it and see what's going on. Great demo. Sorry, James.
It's all right. I think maybe it created the Git repo, but didn't. The files are in a different folder, maybe.
Shouldn't have done that with this. Well, yeah, I'm going to go fix that in a second. We're going to show you. But this is the easy way of using Git, and this is the nice painless demo that I was just about to show everybody. But that'll teach me for using the pre-release version of everything else as well, won't it? Right, that's that there. That's that there. Come in here, make a change. Why is it not in there? Right, I'm going to come back to this in a second. I'm going to show you in regular Visual Studio. We're going to clone it back down again and just start again. So give me a second there, and we're going to do that. But before we do, what I'm going to do quickly here is I've got my Git repository up on GitHub with some files in it. And now that it's up on GitHub, you can actually go and take a look at this. If you go to Martin Woodward console app, you can take a quick look. You can right click, and then I can come in and edit, but you can't come in here. Make some changes. I can make some changes to some files. I can hit commit changes. I can make those changes there. And that's them made. And then what I'm just going to do quickly is reopen this back up. Right. C user source repos console app. We're going to go into here. And then we're going to say, we're just going to go into the command line just to see these files in the command line. Right, so cd source. So there we go. There's cd. I've got my backup one if I can't. Right. Oops. ls minus. Yeah, that is fascinating. Console app. Huh. Cool. Give me 1 second. Just want to check something. Wow, that's sweet. Okay, right. So Visual Studio has been fun, so I should probably just jump back to the previous build of it. And then git push. One last thing. I'm typing a bunch of commands in here. Oh, there we go. Okay, I see what's happened. Right.
So what has happened, Martin? Something has gone terribly wrong in your demo.
Yeah.
And you're like, oh no, I know everything about Git, but I don't know what's going on. What happened?
What happened there? So what happened there, fantastically, is this brand new preview build I've done when I was doing that has decided it didn't want to. I actually know why now as well. I right-clicked on the solution when I was in the Zoom rather than initializing it on the project. And what it hasn't done is it hasn't added the files into my changes.
Oh.
And so what I needed to do is right-click on, and I'm going to do the zoom in so everybody can see this. Thank you, James. I'm going to right-click on here on my console app, and I said Git, and I told it to commit or stash. What a horrible word commit is. But what I'm basically saying is I want to now make a kind of like a line. I want to say this is the point in time at which I want my changes to be done. So I'm going to say, finally figured out why I'm stupid is my commit message. And I'm going to commit all these files. So I'm going to say I want to add all these files into it. And so now that's going to create a change. And you see it's got this really super weird ID here. It doesn't go like version 1, version 2, version 3. It just comes in and it gives you a commit ID locally. So there we go. But that's the point in time changed. And then if I make another change, so if I go over here and I say, hello everyone watching live. That was fun. And then I go back here and I go back over. Oh, no, hit save. And I go back over and look at my changes now. We can see in the Git window that there's one file that's changed, and that's program.cs. And if we go to Solution Explorer, we can see Now, rather than a little padlock, it's saying pending edit on program.cs. And so I can go back to what I was trying to do earlier, which was git and say commit or stash, which it wasn't showing me a second ago. And I can come in and I can say made a change. And I can say commit all. Now, if everyone's following along live, watching, they'll notice none of these files are actually in my GitHub yet. They're all, you see this, created locally. So what we want to do is we want to push those changes to the server. We want to send them from my machine and push them up to the server. When you start using Git, oh my goodness, you'll forget this so many times. You'll be doing it, and you'll say to your friend, yep, that change is fixed, I've done it, I've committed it, it's all there. And you'll realize that you haven't, this little 2 outgoing, 0 incoming, means there are changes that are on the server that you haven't got locally. Now, I actually did a change on the server without getting them locally, which is quite exciting. So we're going to, hopefully it's going to do some stuff. But yeah. So what we're going to do is we're going to press that button, sync or merge. And that is then going to come in and it's going to like create the files on the server. And it's going to synchronize them with the files we've got locally. And it's going to merge everything back together. And it's going to get everything back in sync. So if I go back to my Solution Explorer, we'll see here, console app is just exactly as it was. It's just all the files are just there. That was fun. But if we go up to if we go into the file explorer and we just look at the folder, we can see, as well as the solution file, we've got this readme. And then I'm just going to open that in Visual Studio Code. I know I could do this just staying in Visual Studio, but hey, why not use lots of tools? So I'll get that ready. We'll see that because I pressed the button and told it to synchronize with the server, it's gone and pulled down the changes from the server, synchronized them in my local machine, copied them all. And so regardless of where the changes were made, it's got them back in sync again and all my files are up to date.
Lovely.
So if I go back to the server here and I'm just going to hit refresh onto GitHub, we'll see console app. We'll see that it contains my console app proj file with my changes in my solution. And even better, if we look at history, we can see finally figured out why I'm stupid and then made a change. And we could click on one of those and we can see exactly what changed between those versions. That's the point of version control, basically. Even though it was a terrible demo to start, I pulled it out of the bag at the end.
You did it, Martin.
Yeah, exactly. So we're coming in here and we can see, yeah, I got rid of that and I added everyone watching live. That was fun.
You did it. Now, I think that's the best kind of demos when you use the tools to fix it. And it's a good demo of why Git is important, how it worked. It all worked out great. A few questions for you in here. Some people from Learn TV and from YouTube are asking, we're showing a lot of text files, but what if I have like super large files, like huge images, or I'm a game studio, I got MP4s and I got, 3D renderings and stuff. How do I store those things?
That's a great, that's great. And because as I mentioned at the beginning, Git isn't great at storing those massive files in version control. So the first question is, do you need to version them? Do they need to be part of your source code or not? And ideally they don't. What you can ideally do is what you call externalizing your binaries. So you can take your big binary files, your big dependencies, and have them stored in a package repository. GitHub gives you one. You can get other package repositories. You can store them in Azure Blob Storage, whatever. You know what I mean? Like, ideally, you don't have a ton of binaries inside your code. It's fine to have images and things. It's fine to have, MP4s as well, as part of it if they're not changing all the time. Like, you don't need to worry about it too much. But if all of a sudden you start to see when you're cloning your repository, it's getting really, really big and ginormous, then that's probably a point in time where you think you might need to kind of start pushing some of these out. Now, there is a thing called Git LFS, which I'm not going to go into too much today because that's just quite scary. Yeah. But if you go into your settings, you can actually configure Git large file storage. And that's a way of being able to store large files within your Git repository.
Oh, okay.
However, I work for GitHub. I would strongly recommend you don't use Git LFS for open source repositories today. because the reason why is you get a certain amount of free storage, but then you also have to pay for additional storage. And it basically behind the scenes, it's kind of using blob storage
Got
to
it.
store those things, and so you pay after you've used the free amount. And this is to stop people storing, videos of their families and whatever, or videos that we shouldn't talk about at work and all that sort of stuff. Like
Makes
we
sense.
don't. That's not what GitHub's for. GitHub's for sharing source control, and so you have to pay for this additional storage and things. And if you're doing a lot of open source and you start doing that, then all of a sudden your bill can escalate as things come in. So I don't usually recommend GitFLS, but that's a great question.
Good question. All right, we got a few more here, and then we'll
Yep.
I've been watching a lot of Great British Bake Off, so they always say
Okay,
crack
there
on.
we go.
So,
This is cool.
so I do like the crack on. So good question here. You were committing code. There's also a thing called a stash.
Yes.
Now I personally don't use stash very often, but I have on occasion used it. Can you just quickly explain the difference there of what that means?
Yeah, so you can think of a stash as basically it's like the in tray, and it's a place where you're going to temporarily put stuff
Hmm.
in your stash, and then bring it back out of your stash again. So it's like a temporary storage is where you might want to put things. Commonly, we're going to talk in a moment about branching, and commonly you would use your stash when you want to move things between branches, or you want to just kind of have them. But it's not pushed anywhere. It doesn't go up onto the server and things like that. So rather than, I don't use stashing at all. I know how to use the command,
Yeah.
but that's it. I use branches because they're so lightweight in Git. So I use a named storage, and I just have loads. I have hundreds of them, and I would push some of them up to the servers and stuff because they're more usable then. But yeah, that's what it's designed for, to kind of to share, to just a temporary storage place of files.
Perfect. I love that. Another good question here is,
Yep.
you had to kind of manually check in the files, add the files. You were adding
Yeah.
all of them. A few questions in the chat from a few different people is like, is it good practice to automate it, or should it be like with every character change I'm committing code, right?
Yeah.
Like, could I be like, hey, every day at 5:30 when I check out, commit this? Is that a good
Yeah.
idea?
I actually, so I've debated this myself. That my standard kind of code of practice is when I've got something that works, I'll commit it. Or when I'm at a point in time that I'm happy with, I'll just commit it. And I'll commit multiple times in a day. And I would commit often multiple times before I push, because I've got something working. I want to create a label. I want to create a point in time that I know I can roll the whole file system back to. I've debated a few times, and there is a plugin for Visual Studio Code actually that will commit on every save,
Wow.
which is an interesting thing. Because if you think about it, a save is usually like a good point. But what I tend to do is when I've got something works and the unit tests pass, that for me is 100% a commit point. I'll make a commit and I'll do a few of those, and then when I've got something that works and is good, I'll take those commits and I'll push them to the server so that they're known good. Every day before I finish work, however, I do a commit and a push. And I will make sure that's backed up. Again, it's kind of weird because I've not left this cupboard for like at least 2.5 years. But it's kind of a practice I fell into when I worked in an office because, what if I didn't get into the office the next day? Or, usually when I'm working with team members who are working on different time zones. And so I'll commit and push where I am. I might often create like a temporary, I've talked about branching and I haven't explained it yet. I might often create like a temporary branch that's like my little working space. Again, so I can come back to it and pull it down from the server if I need to on a different machine later.
Got
You
it.
never know what's going to happen to your machine overnight. You can spill coffee. You could have a fantastic party.
That's a good point. Yeah, I agree with you. Like for me, let's say I'm fixing a bug in my code. I
Yeah.
think for me, I don't want to commit all the time because I actually want to see it committed. I want to see the differences like you were showing is here's what went into it. So I actually could look at, oh, what did I do here? What did I do here? I might have multiple commits that go into a bug fix. But to me, the history of that's quite important. But we did get a
Yeah.
lot of questions about branches, and I know that's on the top of your
Yeah,
mind. So
should we
let's
talk about branching and explain all that stuff out? So if we bring up the screen again now, I'm going to jump back to slides. So now when we were doing history there, what you saw us do was create some files in my repository, and then I actually created some files on the server's repository. Is exactly
wait,
what I
who's
did.
Bob? Who is
Yeah,
this Bob
Bob.
character?
Yeah, but Bob's like Alice's nemesis. But Bob is the person that you're working with. So yeah, so there's me and there's Bob. Bob can be James, but whatever. James, it's what we call you behind your back, James.
Oh my goodness.
Yep. So you've got my repository and Bob's repository or James's repository, and you've got the different source code. And then when you take it from your repository and you push it to the server, it's now I pushed up to here. But then if I make another change on my local machine, then my repository is ahead of Bob's repository. Like there's different copies of it. Now, what do we do here? Because this is what's called a distributed version control system. Obviously, if Bob was to create another commit ID, his would be called ID number 4, but his might be different to ours, and like how we'd get confused as to which commits really were which. So Bob would have to create a new commit, and it would have to be called like commit 5, and like you'd get all these changes and you'd try and merge them together. But how do you know this is all how it's going to work? If these commits are numbered like this, how would you number them all and get this all working in a distributed way? And that's exactly the change that we did just now. We made a change on the server, we made a change locally, and then when we pulled them together, we merged them into one file, one particular version called version, not 6, it had that weird, super weird like name, AFGB9 or whatever. It's a hexadecimal string. Now, those commit IDs are actually, and this is why I actually made a joke about blockchain and things, they can't go up one by one because we don't have a server to talk to. Git is what's called a distributed server. So it actually is a cryptographic hash of the contents of the point in time of that tree. And so if you make a set of files or changes, it gives a certain ID, you get a hash, you get an ID, which is a cryptographic hash. Basically, it's just a bunch of hexadecimal characters is all you need to know, and it doesn't go up one by one. But that's why it is. It's because it's just all it is just a cryptographic hash of the contents of your file system and how it's changed from every version in history. So the previous point in time. Now, a branch, all a branch is, previously we were making changes, and we were making changes into a thing called main. You might see the term master, you might see the term main. They're just common names for the default branch, the branch that you're working on. In this example, I've called it mine, just to make it even more confusing. When you're working on a branch called mine or main or whatever you want to call it, and that points to a certain commit. And then Bob might be pointed to a different place right now, but you are pointed to a certain place on the tree. When you make a change, the thing about a branch is it automatically points to the latest version of the change in your tree. So, but remember, Git's distributed. All of these points in time are stored on your machine. And we can show you that, in fact, because because I messed all this up and I was getting really confused, it actually helps my demo. So maybe I can pretend I was doing that deliberately. If I do Git and do view history, which is what I was doing when I was getting confused, you can see there's made a change, finally figured it out. If I want to get into like that's my local history, sorry. And then you can sort of see the different versions, the different commits. They are the different points in time at which I was making it. And you notice it's actually the commit ID is a great big cryptographic ID, but we only tend to show the first few characters of it because
zoom in there for me.
Changed. Oh yeah, sorry James. Sorry,
it's all good. I got you. I got your back.
There we go. So we come in here and we can sort of see there's the commit ID and so on and so forth. Right. A branch just points to a particular commit. And then there's a special branch called head, uppercase head, believe it or not, which is always pointing where your current local file system is located at. And if you want, you can move this head thing around. So you know when you've done, probably when you've said, oh, how do I roll back stuff? And Stack Overflow's told you to do, reset head -1 or something like that, ~1. What you're actually telling it is to move the pointer for the head branch back a step, go back in time one step and point here instead and then take it from here instead. So head is just a special branch. And a branch is just a label that points to a commit which is in a particular point of time. I'm going to skip ahead because we've had some awesome questions. I'm just going to quickly make sure I've summarized this. So branches exist at the whole repository level. So a branch is a point in time of the entire repo. And it's incredibly lightweight. They're not completely free, but they're mostly free. So you can create lots of branches, and it's very easy to switch between branches, and it's very, very quick. So you can create just a temporary branch and leave it, and that's good. And you can just flip between them very, very easily. While I'm here, I'm just going to quickly call out a thing called a tag. A tag, some people call them labels, but Git is called a tag. And a tag is basically a point in time, again, label of a particular commit. But unlike a branch, which moves when you add something to the repository, the tag does not. The tag stays pointing at a particular commit, always, for as long until you edit the tag. And so that's a good way of saying this is the version that I deployed into production. This is the version that I deployed into test, that sort of thing. Does that make sense remotely? James, I'm going to assume silence.
Well, it makes sense to me, but yes.
Yeah. Let's see if people think it makes sense remotely. There we go.
I think so. I think John's helping out some people there. Okay. I think the one question I always have is sometimes I see the thing called detached head, right? And I think that head thing is always confusing because I kind of understand that the main I'm on mine right there.
Yeah.
And I'm here, and this is where I'm currently at. I never really kind of understood like why it's called head or why should I care about
why is it got detached?
Why did it get detached? And what happens there?
Yeah. So right now, the place where your happy path and the place where things are good is when head is pointed to a branch name like mine or main or master. And when head is pointed to that, then it's pointed to a specific branch. And remember, every time you make a commit, that branch will move forwards with you for each new commit.
Got it.
When you've got a detached head, it's no longer pointing to a specific branch name. It's now pointing to a specific commit ID. So it's become detached to a branch. And quite often you get into that state when you've been playing in the command line and you might say, oh, I want to go look at what my whole file system looked like back here before I did the release. So I'm going to roll my head. I'm going to make it point to 6D36FAA. So my local file system is going to look like it did at this point in time here. And you look at it and you think that's great. And then you go, and then you forget you were just looking and you start editing. And so you start making some changes and then Git starts warning you, oh, you're in a detached head state. Because what you haven't done is told Git that you want the master branch or you want the main branch to also be now pointing to 6D36FAA rather than just your local file system. So yeah, I'm probably just making it more confusing, but that's what detached head means.
I think that's good. I think that's something that sometimes people it pops up in there. And like you said, right, you should also be branching quite often, right? And one thing you don't have in here is like branches of branches as well. Exactly. And that's a possibility, correct? And is that a okay use case?
So yes, but a branch of a branch, like there's no real such thing as a branch of a branch. Like it's just there because it exists like that. All a branch is a label that points to a commit ID. And it might be like here you've got mine, but if say we created another one, say release 1 was actually a branch rather than a tag. Mm-hmm. So you could say that mine was a branch of release 1 because it had come up here. But that's just, it's not really. It just is because that you'd have to follow the history back to say that was the case. All a branch is just a pointer to a point in time to a particular commit ID, which is a pointer. So it's just super lightweight. It's literally just a name literal. And you can go look at the file system and see them, and it literally just has name, space, and then the big long commit ID. So that's all it is. It's just a pointer.
Lovely. Perfect. Lots of good comments as well. People saying, yes, it makes sense. Wonderful. John says it's the best explanation of detached head he's ever heard in his entire life.
There we go.
So you're good.
I lost my head. Brilliant. Yes, we're going to talk about Git flow. In fact, I'm just going to quickly show you branching and creating branches and doing all that sort of stuff. And then I'll quickly explain merge, and then we'll do like pushing to an open source repo. Can I have a quick time check, James?
Yeah, so right now we're about 10:22 a.m. Pacific, so maybe around another 15 minutes or so.
Okay, well, this is good. So what I'm gonna do then is I'm gonna quickly make some changes and show you committing them to a repo. That's the best way. Yeah, I think what we'll do. Let's just go do some stuff in the shell, and then I'm gonna show you branches because you
Okay.
can do branches super easily. With the Git repository, you can come in and you can create new branches. You see, I could come here and I could create mine, and then oops, I can actually create mine. Sorry about this. You can create new branches. You can you can change branches, all that sort of stuff. But what I want to do is come in here and show it you from the command line, and I can make this super big. And then you can read it as well. Is that fairly? No, that needs to be bigger. Hang on a second.
Always bigger.
Oh, bigger is better. Oh, sorry, for some reason I know why. It's okay. I know what I've done wrong. Right. How'd you do this in the new shell? You just right click on here and say expandy.
No, just
I was doing option plus, and for some reason,
Control plus should just.
yeah, that's what you'd think. Aha! I know why. Right. Okay. Keyboard.
You're through the Mac through the thing.
Right. So I'm here. So if I do git status, that's going to tell you what you're on, and I'm on branch is called main, and my branch is up to date. My branch is not detached, and my branch is up to date with the server. That's great. So I'm going to create a branch. I'm going to say git branch. Sorry. I'm going to say git checkout -b for create a branch, and this is why people don't use a command line, why they have to look things up. And I'm going to call this Bob because that's what we were doing. Bobs, in fact, because that's what we were doing. I've switched to a new branch called Bobs, and then if I zoom in, see down here in the bottom of Visual Studio when you've got it installed, you see now there it says Bobs. And if I right click here and I go back and go there, I'm now back on main. Left click, sorry. Bobs. So I can easily switch branches super quickly. So if I've got different versions of files, so say there's my program file, and I'm going to say that was fun, and I say here change in Bobs. And then what I'm going to do is just make it super easier. I'm going to come back down. I'm going to say git checkout main. And then it's done. Oh no, hang on a second. Git checkout Bobs. Right. I've got one file. See there, it says it's warning me. It's modified program.cs. That's because I hadn't committed. And again, you're going to do this loads of times. Remember, one must commit when one's using Git. So I'm going to say commit or stash. I'm going to say change in Bob. And I'm going to do that. I'm going to hit commit all. And then if I go back to here, and then I do git status, just to be sure. Nothing to commit. We're all committed. And then I'm going to do git checkout main. So I've now switched to main. If I go back into Visual Studio, come back into my program, look what happened. Did you see that, James?
It's magic.
The change in Bob had disappeared.
Bob's gone.
Bob's gone. Bob's dead, baby. But Bob isn't dead. If I go back to Bob, Bob's back alive again.
Because that was a close one.
Yeah, but this is what source control is about. Because you can use these branches to store your changes when you're in different states, and you can just easily store and then kind of go back to where you want. And so you can have lots of different branches with lots of different kind of statuses, and it makes it very easy to flip back and forth. And then you can compare between branches, you can do all that sort of stuff. So that's what a branch is for just making changes, having a different version of code that lives in parallel. And obviously, quite often you would change multiple files. Yep, let me just check something. But what I want to do now is take my changes between these files, and I'm going to see if I can right click on this. Yeah, that's exciting. Right, I've got one outgoing change and one incoming change. So you see, I've got a change in Bob, which I haven't yet pushed to the server. And so within my Visual Studio, I'm going to zoom in for me. Oh, I know which key I wasn't using now. Hold on a second. Yeah, oh, that's exciting. Right, okay, that's good. I know what I'm doing now. So if I come in here and I'm going to say push. So I'm going to push Bob over. I'm going to send Bob from my machine up to the server. So pushing branch, and that's going up, and that's gone up to the server. It says called it origin. That's super confusing, but we're going to explain why in a second. And it's giving me a thing that says create pull request. Again, super confusing. Let's not worry about that for just 1 second. Because if I go back now to my GitHub repository, we see we don't just have main here, but we now have, hit refresh. We now have main and we have Bob's. And I can see that there's differences between main and Bob's. And you see here, Bob is ahead of main. So there's one change in Bob that isn't yet in main. And that's how you do those. And then if I wanted to, I could compare Bob to main. And I could see what's different. And we can come in and we can look at the files and we can see, make some changes. Right there, we're going to create what's called a pull request. But we see there was one change, one commit that was different, and one file. And it was just that change in Bob's is what we've got here. So I'm going to say make some changes, and I'm going to say create a pull request. So that's please master, please main, accept this change. I hereby present you this change of Bob, and I would like you to accept it into your main branch, please. And so the person looking at this can look, they can see what's different between main and Bob, and then if they want to, they can merge it. They can actually bring that change into the main branch. What happens when we do that? And then we're gonna go back to questions. So when you're merging, you've got merging two commits. You've got Bob and mine. And what you want to do is you want to bring those changes together into a new, what's called a new commit. So mine is currently pointing here, Bob's is currently here. When we merge them together, we're going to get a brand new point in time where those changes have been merged. Now, that's what happens normally, and you get what's called a merge commit. Sometimes you can do what's called a fast forward merge, and there's all these words in Git. They only make sense when you understand kind of like the graph that's coming. Basically, what a fast forward merge does is Git has the option of saying, well, if I'm merging Bob's and main, if I'm merging the feature branch and main together, if I know that the only thing that changed is this, I can just not bother with creating a merge commit, and I could just have main point to this particular commit here. So that's all a fast forward merge is, really. But with our server, if I just quickly go back and have a quick look at our server, if I hit merge pull request, I can actually, I've got some options here, by the way, but I'm going to do create a merge request. I'm going to say create a merge commit. I'm going to do confirm merge. And then if I now go back to my main branch, I can see changing Bob has arrived. And if I look at my history, I can see I merged a pull request from Bob's. There's the change in Bob's that I made, which was just the change in Bob. And then here is that merge where I'm merging it in when I'm pulling these two things together. And so that is this state here where I've merged two things together. So that's all we're doing, and that's why it's creating these merge commits. That's why we make it look a bit weird. It's because it's creating a new point in time where it's pulled them together. Right, let's do some questions. I can do write remotes and stuff if we run out of questions, but I'm pretty sure David's going to get ready to come on pretty soon.
No, lovely. Yes. So lots of good questions here around it. So Some people were asking a little bit earlier about something that they've heard of called Git Flow. Do you just want to
Yeah,
kind of give
okay.
like what that is? I mean, you're not going to show
Yeah,
it,
yeah,
but
yeah,
you know
yeah.
what
Let's
that
do
is.
that super
Yeah.
quick then, because yeah, especially as we've got questions of it. So if you are doing, and I'm going to talk about the GitHub flow, rather than Git flow specifically, but if you're doing working in a fork and pull request model, you've got your changes in your in the open source repository,
Mm,
and then you bring them into a copy of your repository. So we're going to say Martin Corsiello. And then when you want to make your pull request, when I was doing it between a branch, but when you're doing your pull request, what you're actually saying is, please take a copy of my commit from a completely different copy of the repo and bring it into your copy of the repo, please. And so typically that's how you work in an open source repository. You're not always working on Martin Woodward console app. You
I
would
don't have
work
access.
You don't have access because it's private, actually. I should make this
Yeah.
public so everybody can see it. But what you're working in is a here we go, danger zone, change visibility, make it public. Obviously I'm just going to copy paste this because that's what everybody does. And then there we go. So everybody can see that now. But yeah, you wouldn't normally have access, and you definitely wouldn't have access to publish that thing. Oh man, yeah, you wouldn't. I'm just going to skip that for now because it didn't authenticate me because of my 2FA. You wouldn't do you wouldn't have access to do that straight away. And so you take a copy and then you say to the person, please pull it in for me because I do have access. So that's kind of what the GitHub flow is. And then we wanted to, we could show remotes and things, but go on, let's talk a bit more about like other questions, I think.
Yeah, sure. So like one thing here I think is a good point that I want to pull out, right, is
Yeah.
sometimes I make the mistake of just cloning your repo and then I want to make changes to
Okay.
it. So I think like, at a high level when we're talking about even that slide, right, is is that if I want to contribute to your console app, the process is I should fork it, and it's kind of like my own version of it,
Yeah, let's do that. Let's just
right?
show everybody. It's probably
Okay.
quicker. What I'm going to do is I'm just going to quickly do it rather than plugging in my key into Windows. I'm just going to jump here onto the Mac and do it super quick.
Okay.
So if I'm going to go to GitHub, I'm going to go to github.com /octacademy, which just happens to be an open source organization I prepared earlier. Well, it's actually a private one, but I've got some stuff in here. And I got this repo called my Octocat feedback.
Cool.
Now, what you're saying is when you're doing an open source thing, what you do is you fork it. So you take a copy of the repo and you bring it into your local repository.
Got it.
And so you brought that locally. You have a copy here, and this is doing it. And this is actually super quick because behind the scenes, all it's doing is just creating a symlink, actually. But anyway, so now it's up to date with Octacademy main. So you can make changes and you can do some stuff here. So I can come in and I can create a new branch. I'm going to say...
And that's a good question, right? Is you're creating a brand, you forked it, you created a branch.
Yeah.
Is that best practice? I've made the mistake in the past of just committing to main
Exactly.
in my fork, and that seems problematic.
It is. Yeah, you never, ever, ever... if you intend on getting those changes back into that person's repository, it's much easier in life if you've gone and you've worked on your own branch rather than working in main.
Got it.
Because the owner of my Octocat feedback is going to be busy making changes into main all the time. Yeah.
Got it.
So you're working in demo 1, they're working in main. If I make a quick change here, and I'll do this in the UI, and you can sort of see it rather than having to jump back and forth. It's going to say change in Martin Woodward because that's where I'm making it. Yeah, and I'm just going to quickly commit those changes into the demo 1 branch. So there they are. Made those changes. Change in Martin Woodward, and then I'm going to, in a separate tab, go to my Octocat feedback, and you can see here, by the way, that. I've made a change over in that other repository. Would I like to bring it in? I don't at this point in time. I want to make another change in main because I want to make this not the happy path. So I'm going to come in here and I'm going to say, make a change in main. Ha ha ha. And then so now we're going to get what's called a merge conflict as well, but we're going to have 2 problems. So now I've got to change here in main. And over in my other repo, if I look, my Martin Woodward Octocat feedback, if I look here, I don't have that change yet
No.
because I don't have it. But you see, this is a new feature we added recently. You see here, this branch is one commit behind Octacademy main. So it's telling me that my copy is behind the upstream, is behind the open source version. And so what we could do, we had more time. Shay added it to them a command line. We're dealing with remotes and all that sort of stuff. But what instead I can do is I can come in here and say fetch and merge. So I can compare. I can just go bring those changes back, and I can locally now go grab main and have it in my version. And then that makes it a lot easier for me to be able to see what's going on and then be able to push the changes back again and be able to compare my branch with my copy of main, if you know what I mean. Does that make sense?
That's my favorite feature. So kind of what happened here is I'm working over in my fork, right? To kind of summarize it. I'm working over in my fork. I'm just jamming on code. I'm so happy I'm in my branch. But Martin's been crushing it, right? Martin's just like add new features, doing a bunch of stuff. Now at this point, I want to make sure that I don't have any conflicts with Martin's code. So I'm going to say, hey, I'm going to grab and update the main area, and then I can look at my pull request to see if, did I actually have merge conflicts? Basically, did Martin change something and I changed something? We need to reconcile that, right?
Yeah.
That's sort of where it comes down to.
Yeah.
But that fetching the upstream is an important part. And if you're working out of main in your fork, that's where you're going to really have problems, right? Because you're going to try to bring those things up. And that's why working in that branch is so important.
Yeah, so I put some best practices here to try and remember. So always use these feature branches if you're in a shared private repo, like always be working in your own branches, and then merge to main on the server by doing pull requests. That's going to make your life a lot happier if you're all working in the same repo. When you're merging to main, always do that via a pull request. Again, it'll just make your life happier because what you're not doing is creating merge commits locally. It's the point of code review now. And then there's a feature actually in sort of open source repos and then in also the paid versions of GitHub where you can use what's called branch protection. You can actually say nobody is allowed to make a change on main without coming in via a pull request. So you can actually lock that down in your company if you want to, or if you're doing open source projects as well. And we do that with all of our stuff again, just because it's so confusing if somebody's main branch changes underneath them and they're not quite sure why, and it's very easy to get in a mess. Now with Git, you're going to get in a mess. What do you do when you get in a mess? You can basically, I still do this, and I've been using Git forever. And I work at GitHub. Quite often, you get confused. You know what's going on. It's simpler. You just rename the folder that the Git repository is cloned locally into. That's the Git repository is local in. Just rename it. Pull down a fresh version onto your disk, and you start again with history. And that's the great thing about source control is quite often it's easier to just think, you know what? I'm going to give up. I'm not going to figure this out. I'm just going to go to a known good state, pull those changes down, and I know I've got a backup of the changes I made. I can just go compare them, and I can just look them up and do some stuff. So, yeah. Don't feel bad about it. Everybody does it.
Lovely. All right, Martin. Well, I think we're at time for you, and we're going to bring our good friend David Pine on next. But thank you so much for doing this. I think you have a slide about some resources, some learning more. I think we have an entire Learn path and on GitHub and on Microsoft Learn, correct? You got
exactly. So we'll share those links in the chat straight after this for learning more. But yeah. Lovely. Thanks, everybody. Thanks for your time. I appreciate all the great questions as well. Brilliant.
Absolutely. And of course, you can find Martin on Twitter at Martin Woodward, and we will put a link everywhere where you're at. And on GitHub, too. You can follow people on GitHub and see what Martin's working on. How cool is that?
Yeah, that's scary.
All right. Cheers. Have a great evening.
Thank you. Bye.
Bye. All right. Well, now that you sort of have some introductory concepts of what Git is, right? There's so much more to learn. We could probably have Martin talk for probably 8 to 25 hours on just Git. And maybe we'll do that. So make sure you subscribe to the YouTube channel or to Twitch or to the Learn TV, wherever you're at. Martin should probably do that. Just 8,000 hours of Martin talking about Git. I think that's what the world needs. But what we're going to actually talk about now is that now you have the introduction of here's a repository. Here's how you can make changes. Here's the pull request. There's a lot more things that you can do in the world of Git and with GitHub to actually automate a lot of your processes. There's a lot of good questions there. And I'm actually going to bring in my good friend, John Galloway, who's going to be actually hosting the second half of that. Hey, John, how's it going? And you're muted.
I am not muted. I was quick
Okay.
on the draw. Yeah, this is amazing stuff. Like you, I use Git all the time, and I learned a bunch of stuff just watching Martin talk. I saw someone talk about it. It's like chess. It's like it takes, you can learn, you can teach a kid to play it in a day, but it takes a lifetime to master. And I'm constantly learning new, better ways of doing things. I'm really excited about the stuff David's going to be showing, because GitHub Actions they're so much fun. You can do so much with them. I worked with David on some of these things over this past month, and then I've just been playing with GitHub Actions myself, and it's so cool when they work.
Yeah, I'm a big fan of automation. Anyone that works with me knows that I try to automate everything. I hate doing things twice. It just super annoys me. And that's where I think GitHub Actions falls in. But there's so many cool new things. Let's bring David in, and I'm going to drop out. Hey, David, how's it going?
Hi, friends. How are you?
I'm great. I'm going to go. Bye.
Bye.
So before we move on into what you're going to talk about, I want to do the YouTube thing, whatever. Here's all the resources below. So this includes a bunch of stuff. It includes the Git help stuff. It includes GitHub resources. It also includes a link to a blog post you recently published about GitHub Actions, ton of other stuff. So if, for people following along, don't worry, you can go and read up on this stuff later. So it's out in the chat and stuff. But for what we're going to be covering next, what's the elevator pitch? What are GitHub Actions?
GitHub Actions are a way to, as James alluded to before, automate yourself out of a job.
Should I bring up your slides?
Yeah, let's start with the slides right away, and we can jump into demos afterwards, and we'll just work from here. Yeah. Awesome.
Sounds great. Okay, I will watch along, and I will possibly disappear I guess I'll go over here, and I'll disappear myself as needed. So
Awesome.
Go for it.
Thanks, John. Welcome to the second half of Let's Learn Live. This is going to be focusing on GitHub Actions for .NET developers. And my name is David Pine. I'm a host of On .NET Live TV, and along with my fellow co-hosts who were previously a part of the .NET Doc show. You may have seen that. So now we just recently transitioned. I work in DevRel at Microsoft. You can follow me on Twitter at DavidPine7, because apparently I'm the 7th iteration of David Pines in the world that are on Twitter. All of the GitHub source code that you're going to see today is on my account at iEvangelist. And if you're ever curious about other GitHub related or .NET related things, you can check out my blog, davidpine.net. So GitHub Actions. GitHub Actions is a platform first. So there's lots of confusion about the name GitHub Actions and actions themselves and workflows, and sometimes they're used synonymously, and that's an inaccurate assumption. We're going to get into that and kind of disseminate all these different things and provide terminology and real-world examples to help you learn. So the platform is a world-class CI/CD, so continuous integration, continuous deployment. So what that really means is you can use GitHub, what Martin was showing before, which sits on top of Git, and it's fully integrated with GitHub Actions, meaning on certain events, any GitHub event that occurs, we can listen for those things inside workflow files and take specific action. For example, if someone pushes code like Martin was doing and Bob, the Bob fork was doing, if those events happen, we can take action with GitHub Actions. And they're powered by,
Just wanted to jump in for a second. Your audio sounds a little crackly, and I'm not sure, you're an audio guy, so you may have an idea what it is. It may be peaking or something.
Is this better?
Yes.
Okay, I'll move closer to the microphone. Whisper in everyone's ear.
Still is crackling a bit, but yeah, we'll keep an eye on it. You're understandable. It's just a little crackly.
Okay. Should I try to disconnect things or no? Don't go that far yet.
Here, let me see. You probably don't go that far yet. We'll play it by ear. I think it's understandable. And if,
Should I adjust like the echo cancellation? Should I try that real quick? No.
let's try that.
Is this better?
It's quiet.
It's quiet.
But it does sound better.
Okay. Well, I'll do that and I'll get closer. We'll have a real intimate moment here.
You will need to get closer. It is kind of quiet then.
Okay, here we go. So GitHub Actions are any platform, any language, and any cloud. Better still? Good?
I think it's better. I just still heard some crackling.
Okay. GitHub Actions, they're free for public repositories, which is a huge thing. So if you have a public repository out on GitHub, you can use GitHub Actions, and it's quite amazing because you have a huge amount of power at your advantage, and we'll cover that in the demo here in just a second. So
I'm sorry to jump in one more time, but yeah, I think it's actually worse now. I think it was better before.
Okay, let me try.
It's workable. People can hear you. It's just a little, I don't know. It's, staticky is what it's. Yeah, popping. Cool.
Is that better?
I think it's better. Yep.
Okay. I do apologize for the poor audio. This shouldn't be the case. I apologize. So
right.
GitHub Actions.
I'm going to jump in now, David. Here we go.
Oh no.
Go back. Yeah, it's a little bit worse. I don't know. Maybe try to turn off the automatic adjust mic volume in StreamYard.
I did that. I tried that. It's automatically off. And should I turn it up, volume up or volume down? It's at 100 right now.
Maybe down.
Down.
And just keep talking.
How is this? If I keep testing and talking and moving things?
Move it down a little bit more.
Move it down some more. How's that?
It's a little bit better. Let's keep going.
How about if I turn my gain down? Is that better?
Yeah, keep talking.
Testing 1, 2, 3. Testing GitHub Actions. We love you.
It's a little bit. Here's what we're going to do. David, go ahead and refresh the browser. And John and I will talk through this. You might have to re-upload your slides. Maybe it's just something in your browser going on.
All right. I'll be right back.
Yep. You know, John and I are sticklers for good audio here. And that's why we do this. It's funny when David was just kind of hanging out for endless amounts of hours and everyone sounded fine. But
yeah,
we'll see what happens.
We are definitely getting hit by all the gremlins today.
It's okay.
So, you know, in terms of talking about stuff, though, I want to tell a short little story about GitHub Actions. Okay. Because one of the things one of the things I help with a bit is these featured events on the .NET website. And there's a JSON file for this. And several times I've edited it directly in the browser and broken the JSON. And it would affect the website. And I use GitHub Actions to lint the JSON. And it seriously was like click, 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 and it just worked. And then now when I make a change, hopefully I'm writing correct JSON all the time. But if I don't, it's going to watch for that for me. Gotcha. And so that's an example of a small little thing where it's like, you know, like, I don't know, just a sales pitch. Pay attention to what David's going to show because it totally like made my life a lot better as a developer, you know.
There you go.
All right, things David, better now? Or no, still terrible?
Still bad. Do you have another microphone?
I do not. This is my XLR, and I've only had a very, very few number of oddities happen with it. So
that's all right. Well, let's crack on and see what happens. It's not the worst in the entire world, but it is what it is.
Let me try adjusting things a little bit.
I kind of feel like the XLR is like loose or something like that. That's what it kind of feels like, the static on the connections.
Shouldn't be. Press buttons, hope for the best.
No worries.
That's
why we do it live, is how everyone knows it's live.
It's totally live. This is not pre-recorded. Otherwise, I would have tried it again.
Yeah, no worries.
So march forward.
I think let's march forward. Let's see what happens.
Hopefully it's not too unbearable. All right, so back onto the slides. It's free for everyone. The main reason why you want to use GitHub Actions is you can enable status checks within your GitHub repositories. So what that means is, for example, on main, if we wanted to protect main from basically applying rules and saying that you have to have these workflows run and pass before you're allowed to actually, merge those changes into main. And it's it's part of like the whole GitHub flow, right? So it's a certain like that's like the main selling point. So and it helps to ensure that you're not going to have any code in main that wasn't, compiling or tests weren't passing. So it helps to alleviate those things. So GitHub Actions are reusable components. And when you write actions themselves inside the GitHub Actions platform, when you author them, there's different modalities that you can write them. You can write them with TypeScript or JavaScript using, on top of Node.js. You can do so with Docker, and that's where .NET comes into play. So you can have .NET applications running that are containerized, that are actions themselves, or you could even have composite actions. So the real reason that actions are nice is because they can be used within workflows. And workflows sit inside the root of the directories .github/workflows directory. And they're YAML files. So they can listen on any triggered event. You can run shell scripts. You can use pre-existing actions, and they run inside VMs. So let's take a look at the anatomy of the GitHub workflow. So every workflow starts off with a name. This name is what appears under the Actions tab on GitHub. So if you were to go to Actions, there would be the workflows that are listed that are, the discovered YAML files within that repository. Those names are what correspond to the name inside the workflow file itself. These names are also used for status badges. So in addition to a name, you'll have a set of triggers, and that is the on keyword. So you'll say on push to branches main, for example, or on pull request to branches main. So this little syntax right here basically says that this workflow is going to be triggered when there's a push or a pull request to the main branch. Likewise, once it's triggered, you'll have a set of jobs, and every workflow has a set of jobs. Jobs are defined as an array, and each job runs in its own VM and in parallel, unless otherwise specified. But so you can say like jobs build, and the name is anonymous. We can name this whatever we want, and then we'll give it an actual name that will show up inside our logs. So build, we're going to say that it runs on Ubuntu latest, and then jobs will have a set of steps. So steps, this is where the composition comes into play. So steps are either going to use various actions or run just any type of shell command or CLI command. So in this example, we're going to use actions checkout. So this is going to check out the source code. And then we're going to use setup.net. And this is going to set up the .NET environment. And then we can specify inputs. So certain actions require inputs. So in this case, we're going to say setup.net accepts an input of .NET version. And we're going to say 6.0.x, which means it's a floating version, the latest minor version of the 6.0 version, right? And then we're going to do a .NET build. So we're going to run .NET build with the release configuration. Now, the run is actually using .NET, the CLI, and that's really, really powerful. And that was available because we set it up just beforehand with setup.net. So this is a mermaid diagram that I took a screenshot of from our repository, but it's to help kind of visualize the sequence of events. So as a developer, when you push code to main, GitHub's build workflow wakes up as it's triggered, right? And then it does the sequence of actions in its defined steps. So it's going to do actions checkout. It's going to then, if that's successful, it's going to then set up .NET, and then it's going to do a .NET restore, and then a .NET build. So that's just one example of kind of a workflow composition. Now, in addition to workflow composition, and we'll get more into that specifically and how you can rely on other things and some of the details around that in just a second once we do the demo. But we have the ability to maintain secrets. So inside GitHub, you might be thinking to yourself, well, if we're going to publish or deploy some of our code to whatever cloud provider we have, we are going to need some sort of API access keys or tokens or things of that nature. And that's very true. So secrets are GitHub's way of maintaining encrypted, sensitive information for your organization or your repository or individual environments within a repository.
I got to say that secrets part is super useful. When I saw that, and they're like, a lot of workflows will like automatically create them for you.
Mm-hmm.
And that's just like one of those things where it's like, you could go through this automation stuff yourself, but like just that simple kind of polish of like one place you can put your secrets and not worry about accidentally checking them into source control, publishing them out for the world to see and all that.
Right.
So that's like your connection strings for a database maybe, or for publishing to an endpoint, or whatever. It's really nice. Or like publishing a NuGet, package or something.
Absolutely. And the other thing is, as part of the secrets, you actually get access to the GitHub token that is contextual to the action that was triggered. And there's certain permissions that you can flow through the invocation of that workflow. And it's really, really compelling.
Cool.
So awesome. So another thing to be concerned with or mindful of is effective caching. So you can optimize your workflows by utilizing the actions /cache action. And what that does is essentially it allows you to provide a path that you want to monitor, a specific key. In this case, the key is build NuGet with the hashed files. So hashed files is actually a helper utilitarian function that's allowed within expressions inside our workflows. So in addition to our YAML, kind of being just very declarative, we also have a way to provide like dynamic evaluation of things. So that's where expressions come in. So you see the dollar and the two curly braces kind of encompassing the hash files. So hash files is going to look at the packages lock JSON, and it's going to hash that, and that's going to serve as our key. So if our packages actually ever change when we're caching them, they could be restored later for multiple. Like if you're running build a bunch, or you have a huge enterprise where a development team is pushing tons of code, this would really help optimize the speed of those. So rather than restoring stuff and pulling it down into the VM every time, it could be cached and reused, which is very, very helpful. So now we're going to jump into the demo, and that's where we're going to show off a lot more of the meat of kind of what we're looking at. So I put together, if you could just switch slides real quick. Let me make sure that's up. Okay, so this is under iEvangelist, which is my user handle on GitHub, and Actions demo, Actions-demo, and this is already public, so you can go check it out. But it's a simple little Blazor WebAssembly application, and it's got some tests and it's got some code, and I'll show you what it looks like while it's running. So it's basically letting you, modify or look at the mod.NET bot. So this was a little website that was put together a while ago, and you can basically build SVGs, kind of select what .NET bot you want to look like, or, what represents your feeling at that point in time, and you can share it and socialize it. So there's a gallery of all these different bots that exist, and we can just kind of peruse through those. So now, one thing that you might notice if you're kind of a go hard .NET developer is this .NET is it's not the appropriate case, right? It should be all caps, and we wouldn't want to have like these corners over here that are rounded, and it's not even the right font. So the .NET brand, Beth Massey helps kind of maintain this, and there's guidance, there's logo information, there's an entire color guide. And if you open up the PDF for the brand guidance, we talk about what, font family you should have, and all of those things, and all the different colors, what actual hexadecimal values those are. And it's very, very convenient for building out something that might represent, .NET branded stuff. So to that end, in our repository, I just wanted to do this all in the browser as part of the demo. So if you were to go to code and you have access to code spaces, you could spin up a code space. And I've done that already. And code spaces allows me to basically take this repository that we were just looking at in GitHub and use it in the context of a cloud-based, browser-based kind of Visual Studio Code environment. And from here, we have all the code that we were looking at before. So we can drill into the pages. We can find that this is kind of like the title page, and we can see that, this is mod .NET bot. And we see here that this is where the .NET kind of problem point was that we might want to update. So if we were to update this, we actually have a class on this span called .NET badge. So let's go into the CSS. So in here, our CSS is a little bit off, and I do have some CSS. So rather than typing it, I'm just going to go paste this into our window there. And so now we're going to use the open sans. We're going to affix the padding. We're going to get rid of the border radius. We're going to make sure that everything's uppercase text transform, just to make sure that anyone who's using this as a badge, they're going to get the appropriate brand color, padding, border radius, the font family, the font weights, and the text transform. So that's pretty neat, right? So I'm just going to open up our terminal. And then from here, I'm going to do a command, .NET run, and then specify the project. So this, again, is inside the browser, and I have access to the .NET CLI, and I can run that here. So I'm just going to run it. It's going to build it in the browser. It's going to open and port forward over our preview bits, and it's going to run, and you're going to see that that whole branding now of .NET seems a lot more, fitting. We're making the .NET marketing team and our .NET friends in the .NET developer community very happy that we're, correctly representing .NET, right? So from there, how do we get this code into main? So I'm just going to close this down now since our tweaks are kind of good. We're going to stop that. We're going to clear that out. And there's lots of ways we could do it. We could drop down into the CLI from here, and I could just do git add, and then make sure that all my stuff's saved, and then I could add it, and then I could do a commit with a message. I'd probably want to change the branch first. So, or we could do the source control. So the source control, I think Martin did some of that with Visual Studio. So let's just do it this way. So we're going to do git branch. We're going to say updates. That's our new branch name. That's not our branch name. Let's let's go over here. I've got a bunch of aliases set up I forgot about. So let's do get branch. We're going to do create a branch. We're going to call this updates. Adel. It already exists. Ah, that's why. Okay. So let's do another branch name. Create branch updates 2. Ta-da. All right. So now we've got some stuff there. We're going to add a commit message. So we fixed the .NET logo, and we're going to commit that. Hit the check button to commit. And so what it's going to do is it's going to stage them. So it's going to add them, and then it's going to commit them. So it's basically saving those changes and then making sure that there's a SHA-1 that's, a hash rather of those changes in this environment on that branch. So now that they're there, we're going to publish this branch, and it's going to take from our code space, and it's going to push those changes into GitHub. So if we go back here, we go back up to the top, we can see that updates 2 is now live. So what we can do is we can compare and create a pull request right from our ID, right from GitHub. And I'm going to verify that those are the changes I wanted. They are. And I'm going to ping Cam, my good buddy, peer, coworker, friend here, Cam Soper. He's been moderating the chat and interacting with all of you live today. So make sure you thank him. But also, I'm going to thank him for helping me out with this pull request. I'm going to tag him. I'm going to create a pull request. And as part of the pull request, we actually have some workflows inside this GitHub repository. I'm going to show you in a second. But we have checks now. This branch, since I'm trying to merge updates 2 into main is protected. And since it's protected, it's required that it runs these checks first. So it's going to run the build workflow. It's going to run CodeQL, which is a security feature built in and native now to GitHub. So basically what CodeQL does is it will analyze all of our code for potential security vulnerabilities. And it's entirely free of charge, right? For public repositories. So that's super, super powerful. And then it's going to do test and deploy. Deploy, you see that's kind of a compound functionality workflow here. We're going to show you how kind of neat that is because it's got different bits that it will kind of skip over. So, right, so it did the test part passed, but the deploy was skipped because we're not on a certain branch that it's going to look for. So I'm going to hit enable auto merge, right? So once it's auto merged, if Cam was to come in here and approve these changes, what would happen is once all of the builds are considered green, you know, you have a green build, it will automatically merge those changes into main. And then main will have the latest amount of stuff. So we see right here, Cam approved these changes, all the checks passed, and now it's merged. So that's awesome. So if we go back here, we have 2 branches, right? So we've got main and live. Well, live is where we're going to keep our production version of the code. And live has additional protection rules on it as well. So I'm going to show you what those look like in a workflow. But before I do, let's just go over to main or live. This is behind one. Let's contribute here. Can't do that. We need to do a pull request from main into. How do I do a pull request from main into live? I have to do it in the CLI. Let me see. Well, before we do that, let's just look at the workflows really quick. So I have the window open for the .github/workflows directory. And this is where we define all of our workflow YAML files. So in here at a glance, we have Azure deploy, we've got our CodeQL, we have .NET build, and we have .NET test. So let's look at those individually. So the build workflow, again, is named build workflow. And we trigger on a push to main, and we ignore paths, you know, anything that's, if we're just changing the markdown README file, we don't necessarily need to run a build of our .NET code, right? Same thing with a pull request. So this will run and build on a push or a pull request. And essentially what that does is it checks out the code. It sets up .NET in our environment for .NET 6. It will cache all the NuGet bits. And then it does a restore, calling .NET restore. And it does build as a release configuration. And it says no restore because we did restore in the previous step. So that's the build workflow. It's pretty straightforward.
I wanted to jump in with a couple of things. One thing is, first you were saying, how do I do a pull request to live? And I think, if I'm guessing right, if you switch your branch in that, so in code, yeah, switch to live. And then I think you may be able to do contribute from there. Oh.
It wouldn't let me, yeah.
Oh, okay, never mind then.
it said that, I thought the same thing. I was like, well, this would have, you know, seen that it was off, and I thought that it would have said, hey, yes.
Okay.
What if I do from here? No, I don't know why it's not letting me do it. It let me do that before. But anyways, you would essentially take main and you know, push it to live. So
okay.
I'll just keep working through the workflows here. And
so and Cam is saying go to pull request tab on the repo.
Okay. New pull request from here. There we go. And then just say,
yeah.
So is the base the base is main, right? Or is the
you're pushing to main, right? You want to push from line, or no, you want to push from main to, yeah.
Right.
So the base should be, I think
this is where the terminology is confusing for me too.
Yeah.
And I do this a lot.
I think the arrows are, you want to push from main to live. So you should change that one to live, I believe.
Yes.
Pushing from main.
Ta-da. All right. So now this is going to create a pull request. Thanks, Cam. So we're going to push from main to live. We're going to create that pull request. I'm going to call upon Cam once more, the guru of all things. We're going to say, bless this PR. And while that's happening, this is going to do a bit more. It's actually going to end up doing, why is it skipping now? What? Oh, we're going to be made liars very, very soon. But I'll show you the intent here. So the other thing is dotnet test. So dotnet test is very, very similar to dotnet build in that this workflow does a build kind of first. So it's going to rely on, so this works on a push to main or live or a pull request on main. And it does it runs test. So that's the name of the job here. So it's going to check out, it's going to set up .NET, it's going to do the caching, it's going to do restoring of dependencies with .NET restore, it's going to do .NET build, and then it's going to say .NET test, right? And that was the test job. Now at the same level, we have a deploy job identified. And this is the, in this workflow, we've got two jobs. The build workflow only had one job, and it was just a build. So here under deploy, we're going to say that it needs test. So it will never, deploy will never run unless test completed successfully. So we're going to say if the event was a push to live, then we're going to use the Azure deploy. And this is where you can kind of compose workflows and kind of consume them from other workflows. So our Azure deploy is, I'm going to jump over there real quick. Our Azure deploy is triggered on a workflow call. So rather than being on a push or a pull request, this is actually invoked specifically from a workflow call. That means it's called from another workflow, and it defines some secrets. And the secrets that we're going to look for are Azure API token and the GitHub token. And I'm going to show you how those are kind of passed in real quick. Those are the inputs. And if we jump back over to test and deploy, we're going to specify those secrets right here. And these secrets are the GitHub token. It's passed into the secrets of the GitHub token here. And the Azure Static Web Apps API token, that's right there. And that's passed as inputs into this workflow call. And we're going to say deploy. It runs on Ubuntu latest. When the event is a push, it's named deploy. The steps are to check stuff out with submodules. And then we have deploy to Azure Static Web Apps. That's where the app is hosted. And this is another GitHub action that the Azure team put together that lets you deploy your Blazor WebAssembly application to a static web app. So it requires an Azure Static Web App API token and the repo token. And we specify the action which we're uploading. And then we say where our app location is. This is like our contents for the client application, and the output location, which is www root. So if we go back to our top level code and look at it real quick, you'll see that we've got blazor.client app. That's the source for where things are going to come from. And the www client here, this is where things are compiled into and served up from once it's deployed. So I'm just going to hit refresh and I hope that things happen, but it didn't. It didn't deploy. I'm not sure why that didn't happen, but essentially what would have happened in a perfect demo environment and world, we would have had the first pull request from main happen, that means main is, it's got the latest bits. And then we do a pull request from main into our live branch. And then those changes would then deploy this, and then the latest deployment would reflect our changes.
Can we take a look at the action and see the steps that it ran?
Absolutely. So let's go back over to action. Here's the test and deploy. Click into that. So we're going to see it's saying that it skipped deploy on this one, but it shouldn't have.
Yeah. So then
it was skipped entirely, but it should not have been, based on all that. Like, it was working this morning when I tried.
Yeah. So an interesting thing that I've run into with this is there's actually, and this is super nerdy, but I think it's useful to figure out like how to debug and fix stuff. There's an additional hook that you can set for a workflow in addition to like push and commit. There's one it's called like workflow dispatch.
Okay.
And that allows you to actually manually click a button in the GitHub page and kick off the workflow again. So I've been using that one recently. I always have to Google it. It's like it's workflow. I'm just sharing this for if other people run into this sort of thing. That's what I've used in testing them. And then Cam, who's our behind the scenes, the last action ran on push to main. The push to live didn't run for some reason. Yeah. So what I'll do, I mean, of course, you can also just push main to live. That's what people are saying.
Yeah, we did. Didn't we do that? I thought we did that. It says there's a pull request, though. Why is there a pull request? All sorts of things. Oh, this was approved, but it didn't happen? Maybe? Oh, maybe. I know why. Because it was a pull request. It was never merged.
It was never merged, right?
So now it's going to happen.
Point, right? Because you don't want a pull request to push to live until it's actually merged. And this is a great part of like, you can look on the live .NET repos that we use to build .NET, and you can see there's CI that runs, that builds and tests and does all the stuff, but it doesn't actually go into the source or get deployed to the website or whatever until the PR is merged.
Right. So now that it's merged, now it's going to run this again, and now it's going to do the deploy. And then our stuff will have worked, and then we can do a little happy dance and celebrate, and maybe end the frustration of my crackly audio.
And again, though, I think this is great. We're all debugging this together. This is real world, and this is it's working as designed, and it saved us from accidentally like deploying code to production before we'd actually check the pull request.
Absolutely. All right, so that's done. Let's go back here. Now it's running. Deploy. Ta-da! It's working. It's going to work, people. I'm telling you. All right, so what we can do is, if you're watching live, go to the aka.ms/let's-learn-github-actions. That's the vanity URL for the deployed site. And in a matter of moments, it should be live. I'm going to keep smashing it until it happens. And it's going to happen. And it's going to be great. And everyone's going to be like, whoo, celebrate, it worked. Let's go back here. Come on, actions run. It's still running. It's still running.
Well, and another neat thing, there's two ways of doing, there's two schools of thought. One is you mash the refresh button, but I am totally into watching these console commands.
Oh, yeah.
You get the step-by-step, you see exactly what's going on as it's going. And it's super helpful, like as I was debugging actions that we're running, and it'll give you the error message, like, or you know what I mean? It'll tell you what's going on, which is really nice.
Installing the workloads. It's doing all sorts of stuff.
It's all free. Like that keeps blowing my mind, because I'm like, it's doing all this stuff. It's pulling Docker images. It's running all these, and it's all free. It's like,
and I'm pretty sure that the Azure Static Web Apps is free. Yeah. There's a free tier. So literally, free GitHub account, free GitHub Actions, free .NET tooling, free, VS Code IDE, and then just, Azure resources, spin it up. You have a website. It's going to build. It's going to deploy. This one's taking a little bit longer, I think, because the demo gods are frowning upon us today, as evidence to Martin's issues this morning.
Well, if you want to go to other stuff, we've still got a few more minutes. Was there more stuff you wanted to wrap up with, or like?
No, there's not
Okay, well,
too much more.
I
but
want
we
to
can-
ask one question if you hadn't gotten to it,
Mhm.
which is you've shown the YAML way of doing things,
Yes.
which is cool, and that's where you actually go in and modify stuff.
Yep.
Did you show going into the Actions tab and just saying add an action and doing it like through the UI?
Right. Yeah. So that's probably like the, one of the most basic or user kind of centric ways of doing it. So this is almost done deploying. So let's jump back here real quick. So what we can do is from here, yeah, we're going to leave. But if we go to so from Actions, right?
Exactly. And then you can do
New workflow.
And I've got a request if you don't have one.
Okay, well, give me 1 second because now this is done. It's
Oh,
done.
good.
It's deployed. So now
Oh
it's
my
live.
gosh.
So now I can go back over here and we should
So
watch
exciting.
this. Hit refresh. Ta-da! Hey, it looks woohoo! Awesome.
That's
All right,
amazing.
so our demo
Okay.
worked. It worked. All right, so
And
let me
I think what's important too is, again, this is all working like as designed. Sometimes it takes a little longer to build and
Mhm.
everything, but you can see the output. You can see as it's running. I have one that I would like to add on here, which is one of my new favorites.
let's do it.
It's called Super Linter.
Super linter. Like that?
It's got a dash, super dash linter. And just say configure.
Okay.
Okay. I'm backseat driving and like totally like okay. You don't have to change anything. Just say start commit.
Oh, wow. And just go straight to main. We're good?
Just commit, right? Yep. Throw it on in. So what this does, this is a linting action that just verifies like if it's a JSON file, it's well formed. If it's markdown, it follows like standard markdown format. If it's, verifies your README is like fine. It also includes linting for C#.
So linting code base.
Yeah.
So
it'll actually check your like code formatting and stuff. So
do you want to look at the output
Sure.
here? Okay.
Yep. So you can. So the only thing I wanted to throw in here is you can dig into the YAML, which
Mhm.
you've shown.
Yep.
You can totally customize everything you want there. But you can also start playing with these. And this is how I started learning is like
Absolutely.
just go in, configure one, and like you'll see. And this one's more like it's not a whole bunch of lines to set up. And it's just like,
That's really cool. Another thing that people might be interested in that I didn't have prepared to cover, but I'll show you. It's kind of like a free of charge. So as this is going, now that we're in the context of this, lint code base workflow, we can actually right click up here and say create status badge. And what this does is it gives you the markup, the GitHub flavored markup for the status badge itself. So right now it says lint code base because that's the name. There's no status. It's pointing to the default branch. We're going to copy that. And while that's running in parallel, we're going to run over here to our markdown README. And we're going to say, edit this. And we're going to throw in another badge because we've got plenty of badges here already. Just paste it in. We're going to go look at the preview. The preview here says we've got our build workflow. We've got our test and deploy workflow. Now we've got John's new added live while coding lint code base, no status because it's still running. And then the code QL. And then for the heck of it, we've got a mermaid diagram right in our markdown. So mermaid sequence diagram. This was recently announced and it's pretty cool. It's part of GitHub. So as part of that, they now support mermaid. So that entire sequence diagram is fully automated and generated on your behalf, thanks to GitHub and our friends at Mermaid. So I'm going to go ahead and push this little change into main that adds our new status badge. And if you recall, we were ignoring changes to the markdown. So nothing should run except for maybe the linter that we just added. But let's just run that real quick here and see. So that's still running. Go back over here. So now it's done. So what is it? What has it done for us, John? Is it to create a pull request? Is everything great? Does that mean I wrote perfect C# code?
I think it does. And you can actually see in that if you expand lint code base, and it'll show you the things that it ran.
Ooh, look at this.
Yeah, I know. Pretty ASCII art and all that kind of stuff. Yeah, and so it'll say like, and for depending what you did, it may sometimes it's like a no op. Like if you didn't change code that needs to be linted, it'll basically like, so that may be, I don't know, or maybe you have to command F5 or whatever to, but it'll go through and it'll say like found these changed
okay.
files or whatever. Oh, look at that.
Sweet.
So it's saying, hey, here's some issues they're warnings, right? And it's stuff to look at.
And the irony to all of this is it's the super linter YAML itself. So it's saying the stuff we gave you is not great. No, it's probably intentional though. They probably designed it that way so that they would say, here's something, right? It does do something. That's cool. Awesome.
Well, so we're down to just a few minutes left as we're wrapping up. So do you have like summary slides or do you want to?
Yeah, go to summary slides. Yep.
Awesome. So let's switch back over to that.
So that was the demo. Hopefully you saw, kind of workflow composition, the power of the GitHub Actions as a platform, the different ways that they can enable status checks, and how you can really work with a very common developer, Git workflow. So I encourage you to try Actions today. Again, they're free for public repositories. They're amazing. As soon as I started playing with them, I fell in love. I'm a big nerd for them as well. So I've written plenty of GitHub Actions that are being used. So it's, really, really fun. These are the additional GitHub resources. And I think we've shared that link already before. So with that, that's my portion, and I'm happy to answer questions.
All right. Well, we are pretty much at time. So I'm just going to make sure we share. There's the link for the resources. Like David has written one post that's already live and another that's going live very soon. And those are linked in there that talk through all this stuff. Give a ton of, actually, did you show that blog post?
I did not specifically show it. No, not the link for it.
It's good. It's worth actually. We'll run over a minute or two. You can bring up the blog post, and we'll show that because it's fantastic and it gives so much more, like more than you have had time to kind of go through.
Click
here.
Click.
Yeah. So yeah, just this is describing in more detail. Sometimes I need to, I'll get a little lost watching something on a video and I'll need to reread it a few times. So there's tons of information in here. So yeah.
Yeah, definitely check it out.
Wonderful. All right. Well, thank you so much for great presentation, great information. I hope for people watching live that they are inspired to go and try these out. Like just turn on some of these and you'll see how quickly you can increase your productivity, catch the errors before you merge the pull requests and all that kind of stuff.
Awesome.
So awesome. I think with that, we are ready to wave goodbye. So thanks everyone for watching.
Thank you.